economy today is for transportation. We get diesel fuels for rail transportation, for shipping transportation, and of course for the trucking industry that run up and down the highway, and a lot of our automobiles use diesel. Then we get a large percentage of gasolines, the naphthas, that come off of this, and also a large percentage of kerosenes, which are our aviation fuels. And to give you an idea, we don't think about it much. I was standing out here in the parking lot a couple of days ago, look up into the sky, and I counted 13 contrails, 13 different jets going in different directions. I could count from right here, this facility. If you fill a 737 with fuel, if you completely fill it, most of the time when we're taking short hops in a 737 around the country, we don't completely fill them with fuel. But if you completely fill it with fuel, it would take 3 rail cars of fuel to fill one 737. That's a lot of fuel. And that's the bulk of where our hydrocarbons go today, the fossil fuels that we use in transportation, in the aviation industries, in the automotive industries, and of course the shipping industries. So if we can produce a fuel here that will help offset some of the use of those fossil fuels, we will then be able to prolong the life of the fossil fuels that we have for the products that we really need. Most of us are not aware of the literally thousands, hundreds of thousands of products that we use daily that come to us as a direct result of fossil fuels. For example, the next time you take a spoonful of Pepto-Bismol, I want you to think that you're taking a spoonful of oil. Pepto-Bismol is produced directly from hydrocarbons that are taken off of crude oil. So think about that. There are just tons and tons and tons of other products that we use daily that we don't ever think about that come to us from these fossil fuels. So if we can limit our dependence on the fossil fuels for transportation by producing a viable alternative that has previously been mentioned, carbon neutral, or actually has a benefit in offsetting the carbon that we're currently emitting by use of these fossil fuels, you look at the advantages that we have. And again, we've already discussed the agricultural advantages to our region, the economic, we'll talk about that in a little bit here, the economic value to the region. It's tremendous. So we're very excited about the project. We're very excited that you all are here. I'm excited to be able to show you what we've got going on in the backyard when we get out that way. For those of you who are interested, and I'll be available to answer any questions about that facility. Please don't ask me any questions about grass. And again, you've seen this slide. Calvin showed you this one. Looking ahead, these are some of the things that we're trying to do. Any quick questions at the moment? Yes, sir?
I'm kind of curious about the energy balance. How many BTUs does it take to make the butanol compared to the butanol energy density itself?
It's a good question. I have no idea. That's part of the research that we're going to be doing, is to determine what the energy input is versus what we get out of it. Right now, I can tell. Right now, it looks favorable. We think that it'll be a fairly low energy input. One of the neat things about this as well, when we produce fossil fuels, it takes a tremendous amount of water. In our project out here, our plan, the initial water that we put into the system will get recycled and put back into the system to help produce the next batch. So we don't see a lot of water usage in this production facility out here as well. So as we boil the water off to capture the butanol, we'll recondense that steam that we boil off back into water, and then we'll filter that water and reuse it in our next subsequent batches. Again, right now what we're firing our boilers with is natural gas. Natural gas is relatively cheap and it's abundant. There may be other fuel sources that we can use later on, and that's part of what we'll look at to determine that very thing. That's part of the research, and we honestly, until we actually start running some full batches, we won't have an idea of what the actual cost will be. I know that by running pneumatic pumps and doing other things to cut down on the energy usage, and by utilizing solar systems that we'll be able to cut down on the energy usage. So the idea is to produce this with as low energy input as possible. But again, that's part of the research, and only time will tell. Once we actually run a few batches, we'll have a much better idea. Yes, sir?
You mentioned your waste stock that you're going to pelletize it. And then two questions on that. One of them is, would it be certified organic for food stock or livestock? And the second question is, can you use that pelletized material to fire your boilers through a pellet stove?
The second part of the question, the answer to that is yes, we possibly could use that as a heat source. The other thing that we're giving some consideration to is using thermal solar to preheat before we bring it up to temperature. So eventually we hope to have some thermal solar panels out there as well to preheat the liquid before we actually bring it into the boiler. As far as your first question was?
If the feedstock for animals would be certified organic because it's from your agricultural sources, is it going to be produced organic?
My initial response to that is that yes, it would be. We're not doing anything to it that's really going to modify it, other than breaking the cellulose down and converting to sugars. But we do know that there'll be some protein value left in the bottoms product. But again, we're going to have to do some testing of that to find out exactly what's left and what's in it. And until we start running the batches, we're not sure. But that's part of the research. That's why we're here. That's why we're doing this. Well, right here.
Yeah, we've heard some good things about the land resources for local energy production. I'm wondering if you might be able to comment on the labor resources that would be involved in this cycle. And first of all, how labor intensive is the production of butanol in the system you explained? And is there crossover between the skills that are being developed in oil and gas to the skills that could be used in bioenergy production?
Well, how labor intensive it is will depend on the type of facility that you build. The more automated your system, the less labor intensive the actual physical opening and closing valves and so on and so forth. But it will be much like running a small refinery. It won't be as complex because when we break down hydrocarbons, crude oil, there are multiple strings that we're taking off. We're getting a lot of different products off at one time. Whereas in our process, it's basically a binary distillation where we get water off one side and the butanol off the other side. So it's it is not nearly as complex as a refinery, but it's pretty much tantamount to running a refinery. It's a basic binary distillation unit. And then again, depending on how automated your system is, what your grinding facility is for your feedstock and your injection systems, all of that will determine on how labor intensive it actually is. I've got pretty cheap labor because I have students. Did I answer?
Well, and maybe you could comment on the training that's going on at CMC with the students and what skills they'll have to be able to disseminate out to the larger area.
Absolutely. Right now, the process technology program, the automated instrumentation programs that we currently run, we've got an AAS degree in process technology, which is basically process operations, learning how to handle, manipulate, and control what we call the process variables. Primary variables, pressure, temperature, level, and flow. And what we tell our students is, we don't care what runs through the pipe. It could be crude oil, it could be gasoline, it could be tomato juice, it could be mineral slurry, it could be wastewater. We don't care. Our objective is to learn how to handle and manipulate and control the variables. So that's what we train for and teach here, so that students can take the skills that they learn here to any industry. They could be applied in any industry. The automated technology that we train for here is the same automated technology that is utilized in every industry. Every industry basically uses the same type of automation equipment. We don't think about it much, but basically walk up to a vending machine in this day and age and you take a dollar bill out of your purse, pocket, wallet, wherever you store your funds, put it into the machine, and you're taking an analog signal, a piece of paper, putting it into the machine and you're expecting the machine to do something with it. Well, first of all, it's got to recognize that piece of paper and assign a value to it. Second thing that has to happen is, based on your input, you expect to receive a product of your choice based on that input. And if for example, if you're going to get a Coke in this day and age, I don't know where you can buy a Coke for $1, but particularly in a vending machine. So you might have to put $2 in there. So now you're anticipating something else. Not only anticipating getting your product back, but you're anticipating getting the appropriate amount of change. Well, everything in this day and age is electronic. It's digital. So we have to take that piece of paper and convert it to a digital signal. Once we do that, then we have to convert that into a mechanical, back to an analog signal. When you push the button, you expect a physical thing to happen. You want it to give you your Coke, you want it to give you your change. Okay, so we convert back to a physical. That's instrumentation. The automated controls that control the HVAC systems, air conditioning, heating systems in your home, those are the same types of systems, and it takes the same type of controls to start a compressor for your air conditioner, or to start a pump, or to start a motor, as it does to start all of this equipment that we train for out here. It's the same type of system that flows through, the heating system that flows through your home, depending on the type of heating system that you have, the same type of controls. So all of these automated technologies that we train for here are easily transferable from industry to industry to industry. We have one more quick one back here, I guess.
Yeah, so are you going to develop the microbes here, or are you going to partner with another lab so that you get ones that are specific for the biosynthesis of butanol, or how are you going to address that?
Initially, we'll get them from an outside lab. But my colleague right back there, Nephi Thompson, hi Nephi, he's my chemistry guru. So I'm going to depend heavily on Nephi for advice in that area and where we actually get the enzymes. And I know that once we get our bacteria and our enzymes in-house, that we're going to do some experimenting with those, and we'll end up growing some of our own and trying to cultivate. But again, that's Nephi's department. I know nothing about that. All I know is what he tells me to put in the tank.
All right. We have time for about one more question for John.
Do we have one back here? Anybody else have a question?
That was my question. The biochemistry sounds complex.
It is complex, and the guy that's sitting next to you there, that's the guy that you want to ask those questions about. I'm going to punt that one to you, Nephi.